Okay, so there are six types of functions that you have to know at grade 11 level. And I think at grade 10 you were introduced to some of them. The first function that you have to know is the quadratic function. I'm just going to write all of them down quickly. So, like I mentioned, the first one is the quadratic function, sometimes called the parabola. The second one is the hyperbolic function, sometimes we call it the hyperbola. The exponential function, the sine function, the cosine function, as well as the tangent function. So you have to be able to interpret, identify, and draw these types of functions at grade 11 level. So the other thing we can do before we treat the individual functions is that you also have to know the general formula of this function. So this is the general formula for the quadratic function or parabola. What you will notice is that x actually is to the power of 2. So that's why it's called a quadratic function. So you can actually open two brackets and multiply them out, and you find that x is to the power of 2. So that's what we call a quadratic function. This is how you identify it, right? And then with a hyperbola, the general function is the general formula is like this, where you see that x is actually at the bottom. So you have a sort of a fraction with a numerator and a denominator, and at the bottom there you have your x. So that's how you would identify that this is indeed a parabola. And then with an exponential function, you notice that x is actually the exponent. So we have a multiplied by b, all of it which is raised to the exponent of x plus p. So x is your exponent, hence we call it an exponential function, right? And then these ones, I'm sure you're quite familiar with them if you did trigonometry. So these are your trigonometric functions. So you have your sine function, where you have your sin k x plus p, and we're gonna explain all of this, so don't get discouraged or as to what is p, what is k, and what is a, and all of this, right? And then this is your normal cosine function, right? And this is your normal tangent function, tan, right? So these are your trigonometric functions, right? So I'm sure you're already familiar with sine, cos, as well as tan, right? So these are just their functions. So essentially what you will need to know, for example, let us take for the parabolic function, which you're going to start with in this lesson. You will need to see what happens if the value of a changes. So let's say we had the value of a 1, and then in the next graph the value of a is 2, then as it can continue up until, I don't know, a million. And then you have to check what happens to my graph. The same thing with p. What happens to p if p is 2, if p is 3? Something you'll notice them when you plot them down, that something happens, they change, as well as q. So all of these parameters, a, p, q, as well as k, we're going to investigate their effect. So we're going to investigate the effect of a, of p, of q, as well as of k on all of these functions. What happens when we change the value of q? What happens when we change the value of p? What happens when the value of k changes? What happens, right? So let us just try to do that with our first function, which is going to be a parabola or a quadratic function. So let us start with the quadratic function, and this hopefully will serve as a sort of revision to something that you already done in, what is it, in grade 10, right? So the general formula, let us start with our general formula. We said the general formula for our quadratic function is, so the general formula for our quadratic function is y f at x equals to a x plus p, all of it which is squared plus q, right? So but then I want us to take the simplest case where we say in this instance, so we're gonna let me just quickly try to see if I can focus this a bit better. So our first task is that we're actually going to investigate the effect of a on our graph, the effect of a on our graph, right? This a that we're talking about there. So let us take the simplest instant where we say a in this function is equals to 1, p equals to 0, and q equals to 0. So if a is equals to 1, it means that our graph or our function will actually be something like this. It will just be a x squared, right? And then we said that a is equals to 1, so our function will just be x squared, right? So our function will just be f at x equals to x squared. So let us try to plot this function over here. So we can do that. Sometimes you can just do this using your calculator, or you just in this instance I'm going to use the table method. So we've drawn our table over here. So we're starting with x, which is our independent variable. Independent variable. Our y over here will be our dependent variable. You don't need to worry too much about the dependent variable. It's just for you to know for now, right? So if this is the graph we're plotting, f at x is equals to x squared. So if x equals to -2, what will the value of x squared be? So if we have a thingy that says y equals to x squared, and we say that our x is actually equals to -2, what will the value of y be? Can see that it's just the square of -2 will just give us 4, right? Cool. I hope you understand that, and I hope you can do the maths, right? Then the same thing when x is 1, what will the value of our value be, right? So if x is -1, our value is going to just be 1. If x here is 0, it's going to be 0. If x is 1, it's going to be 1. If x is 2, our value is going to be 4. So if we have your x and y coordinates, it means that we can actually plot a graph. So let us try to do that quickly. So I've just quickly drawn our Cartesian scale where you have your y-axis and this side you have your x-axis, right? X-axis. And we're going to try to plot this graph. So we have our coordinates, we have -2. When x is -2, y is -4. So this is our first point. When x is -1, y is 1, right? So this will be our second point over there. When x is 0, y is 0. When x is 1, y is 1 as well. And then when x is 2, y is going to be 4. And then so we have our coordinates. Let me just remove the dotted lines. So there we are. So there are our coordinates. We can just try to draw. If we draw a line through them, this is the shape you're going to get, right? So you draw your line through this point, and this is actually the shape of what we call a quadratic function. It's almost like it's a smile, right? If you're smiling and you're happy, this is what it's going to look like, right? With a minimum there, right? Cool. So we see now that when a, remember we are investigating the effect of a. So when a is one, or in this instance is positive, our graph is actually facing up. Let us see when a is -1. So let's say a equals to -1. Our p is still equals to 0, as well as q is still equals to 0. So we can draw another table over here. Let me just quickly do it. So if we go back to our general formula and a is equals to -1, p is 0 and q is 0, it means our function is actually just going to be y equals to -x squared. So now what will happen when so in this instance our a was +1, it was positive. Our graph is going to be facing up. It's almost like you're smiling, you're happy, right? When you're smiling, you'll see what happens when a is actually negative. So let us plot that. So when x is -2, what do you think the value of y is going to be? So let us start with can just do the first calculation. Here we say x is negative. and then we have negative 2. So we know that negative 2 squared is going to be 4. It means that our value is actually going to be negative 4. And then when x is negative 1, it means our value is going to be negative 1. You can put it in your calculator. And then if x is 0, it's just going to be 0. And then if x is 1, your value is going to be just negative 1 as well. And your x is positive 2, it's still going to be negative 4. So we have our x and y coordinates, we can plot them, right? So we say, okay, when x is negative 2, this is negative 2, y is going to be negative 4. It means that point is going to be over there, right? Let me just draw a circle. And then when x is negative 1, so there is negative 1, y is going to be negative 1. So it means that point is going to be somewhere here. Then x is 0, y is 0, it's still going to be there. And then x is 1, y is negative 1. It's going to be there. X is 2, y is negative 4. It's going to be there. What are you noticing about the shape of our graph, or our function at least? It's actually facing down. It's almost like here you are sad. When you sad, you smile, right? So that is the effect of A. So that is the effect of A. If A is positive, so these are your takeaways from here. So if A is greater than 0, it means that it's positive. Let me just write the term positive or plus sign instead of writing, and I'm wiping with my mask now. So if A is positive, your graph is going to, your function, your parabola is going, or your quadratic function is going to be faced up. That's something you have to know. And it will have a minima at this point, right? Or at the bottom, right? And then it will actually just have a minima here. So I don't want you to get confused, because we're still going to talk about when this graph shifts up and down, right? So, and then if A is less than 0, your graph is going to be negative. Oh, I'm lying. If A is less than 0, it means your A is negative, right? So if your value of A is negative, you have to know immediately that your graph is actually going to be faced down. It's almost going to be like you are sad, right? So remember, A can also be positive 2 or negative 2 or positive 3, negative 3. It can take any value. The important thing is for you to know that if that value of A is negative, your graph is faced down, your parabola is faced down. If that graph of if that A value is positive, your graph is going to be faced down, and it's going to form this shape of sort of a smile facing up, or if you said, your mouth is going to look like a faced down C, right? With a maxima right there. Cool. So let us move a bit along, right? So now what we're going to do is that we're going to investigate the effect of Q, right? Let me just write down the effect of Q, right? We're still doing the quadratic function, right? So let us say in this instant, we had that our A was 1. So if A is positive, it means our graph is going to be faced up. And then our P is still 0 in this instant. We'll still investigate the effect of P, and you'll see what happens. But then let's say Q in this now was all of a sudden 1. So it means that our function is going to look like, so A is going to be 1, x plus 0 all squared, which should give us plus 1. So you don't need to write that 1 there. It means your thing, and x plus 0 is just x, meaning your thing is going to be x squared plus 1, right? Cool. So it means that we're going to be plotting a function of x squared plus 1, and you will see what happens. So we're still going to do the same thing. We're still going to draw a table quickly. Can just draw it quickly. I'm going to do it as well really fast. So now, so we have x, if x is negative 2, so you fill these values yourself. If x is negative 2, what will y be? So y equals to x, so said our x is negative 2 plus 1. So this is going to be negative 2 squared is 4. 4 plus 1 is going to give us 5, right? So now let us change. X is now 1. 1 squared is 1 plus 1 is going to give us 2. And then we have, if x is 0, 0 squared is 0 plus 1 is going to give us 1. The same thing, 1 squared is 1 plus 1 is going to give us 2. Here, 2 squared is going to give us 4 plus 1 is going to give us 5. And now our task is to just simply plot this graph quickly. So we have our Cartesian plane over here, right? And we know that A is positive, like we've just done previously. If A is positive, like I said, your graph is going to be faced up. It means your graph is probably going to look something like that, right? So you know that. So now let us plot our coordinates. So they say that if x is negative 2, y equals to 5. Okay, let me write 5 there and 6. So remember, when you're plotting this, make sure that everything is drawn up to scale. Normally you'd be given a graph paper. So x is negative 2, y is 5, right? It's going to be somewhere there, and then you have your point there. X is negative 1, y is 2. So your point is going to be there. X is 0, y is 1, right? X is 1, y is 2. And then x is 2, your y is going to be positive 5 using these coordinates, right? And then you can actually now draw your graph. You must notice something in comparison to that graph that you first plotted of y equals to x squared. What are you noticing? It seems as if our graph has shifted by 1 point up. You see? So normally that graph, it would have its minima here. But it seems like every point has actually shifted by 1 point up, right? And that is the effect of Q. That Q, we actually call it the vertical shift. So your function has shifted by 1 because our vertical shift was 1, our Q was 1. It has shifted by 1 upwards. So it says plus 1, hence it shifted by 1 up, right? So let us do another case where Q is equals to let me just wipe this quickly. So in this instance, we can say, okay, A is still 1, P is still 0, right? And then Q now is 2. And knowing what we know now, it means that the original graph, which was when we draw it, let me quickly draw that original graph. So look here, this is the graph of y equals to x squared. Now this is the second graph here that we just drew, is y equals to x squared plus 1. What are you noticing? Every point has literally shifted up by 1 point. This point, these coordinates were here, now they are here. And that shift is only in the vertical direction. The value of the x coordinates remains the same. However, the value of the y coordinates have shifted by 1. So here the y coordinate was 0, here it's 1. Here the y coordinate was 1, here it's 2, right? Just a matter that I didn't draw this according to scale. Here the value of the x y coordinate was 4, here it's 5. So everything has shifted by 1. So that is the effect of Q there. So it means also that if now Q equals to 2, our graph is going to lift up by 2 points in the vertical direction. The value of the x coordinates are going to remain the same. However, the value of the y coordinates are going to shift in comparison to the original graph by 2 points upwards. So let us try to do that. Do the same thing, draw a table quickly, right? And then you write your x, y, and we start from negative 2, negative 1, 0, 1, 2. And we say, okay, so if x, wait, where's my graph? So remember the graph that we're trying to plot in this instance, I hope there's enough space. We have y equals to x squared plus 2. The vertical shift is 2. Q is 2. It means our graph is going to lift 2 points up, right? So if we're doing that, so if x is -2, we know -2 squared is 4. 4 plus 2 is equals to 6, right? -1 squared is 1. 1 plus 2 is going to give us 3. Then 0 squared is 0 plus 2 is going to give us 2. 1 squared is 1 plus 2 is going to give us 3. 2 squared is 4 plus 2 is going to give us 6. Hopefully you are able to do this. This is simple maths, right? And now we try to draw this graph, right? So let us draw it. I know my board looks a bit dirty. I hope you can still follow. So if x is -2, now our y is actually going to be 6. If x now is -1, our y is going to be 3. If x is 0, our y is going to be 2. If x is 1, our y is going to be, how much is it? X is 1, our y is going to be 3. If x is 2, our y is going to be 6. So, okay, that is a lie. So that point is going to be, it's not a point there, right? And then we can simply draw that graph there. So what are you noticing? Our point is almost like the origin of this graph has shifted a bit ahead by 2 points. Everything has shifted from our original graph, which is y equals to x squared, to y. So remember, this graph is y equals to x squared plus 2, right? So it has lifted by 2 points upwards. So I hope that is clear and you can be able to see it. And next week, let us try. So the same thing can happen. So now let us say in this instant, your y, your p, try to plot graphs where q is equals to -1, as well as q on your own. This is something that you do on your own. And now q is equals to, so a is still equals to 1. And okay, let me write this properly. So we have that the graphs that I want you to draw, a is still 1, p is still equals to 0, and q now is -1. The second one, a is equals to 1, p is still 0, and q is -2. But it should already tell you something. What are those graphs going to look like? So your graphs are going to be, your functions or your formulas are going to look like y equals to x squared -1, as well as y equals to x squared -2, right? Cool. So what is that telling you? If this value is negative, it means that your graph is actually going to drop by, it's because a is still positive, it's still going to be faced up, but then it's going to go down by, from the original, by 1 point downwards. If it's 2, it's going to go down by 2 points downwards. And try to play with different graphs where now perhaps a is negative, and then you still have your +1 negative, or +1, your q being +1, your q being +2. Try to do them on your own so that you can see the effect of these various parameters. That is something you can definitely do on your own. So now let us try to investigate the effect of p, right? What happens when we change p? We're still talking about the quadratic function, right? So the effect of p. So let us say in this instance, we have a equals to -1. So if a is negative, remember it means your graph, your parabola is going to be faced down. And let us say our q is, let me say our q is -1 as well, right? Cool. I don't hope you don't get confused, but yeah. And let us say in this instance, our p is, okay, let me first do one where q is actually 0. And then we'll do the other one next. So our q equals to 0 and our p is equals to 1, right? So now we're going to investigate the value of p. Cool. So it means that our function is going to be y equals to negative 1 x plus 1 and then q is just going to be 0. You don't need to write it. It means that our graph that we're plotting is just going to be, oh, this is squared. It's just going to be negative x plus 1 squared. So that is the graph that we're trying to plot over there, right? Cool. So still doing the same thing. We draw our table. Just gonna quickly draw it. So let us continue, right? So let's say we have x is equals to negative 2. So if x is negative 2, negative 2 plus 1 is going to give us negative 1. Negative 1 squared is just 1, and then multiply by the negative. Our value is going to just be negative 1, right? And then negative 1 plus 1 is equals to 0, right? 0 squared is just going to be 0. And then 0 plus 1 is 1. 1 squared is 1. But because we have a negative, you multiply that by a negative 1. And then 1 plus 1, if x is 1, is going to be 1 plus 1, which is 2. 2 squared is 4. 4 multiplied by that negative is going to give us negative 4. And then if x is 2, by 2 plus 1, which is 3. 3 squared is going to give us 9. 9 multiplied by a negative is going to give us a negative 9, right? Cool. So now let us try to plot these graphs. Negative 6, negative 7, negative 8, negative 9, right? Cool. So we have x is equals to negative 2. So if x is equals to negative 2, y equals to negative 1. So it's here. So we know our graph is going to be face down because our a here was negative 1. And then x is equals to negative 1. If x is equals to negative 1, y is 0. So this point is over there. And then when x is 0, right, y equals to negative 1. So that point is over here. When x is 1, here, y equals to negative 4. So there is our y. Our y is going to be somewhere over there. If x is 2, y is equals to 9. So maybe our y is going to be just here. I know it looks funny, but it's actually the right graph. So you can just draw there. It's still your, what is it? It's still your parabola. You know, if you when you draw this according to scale, your graphs are going to look much better, you know, right? Cool. So that is what we have. What are you noticing? It seems like if our graph was normally at the origin, right? Remember that graph was somewhere here at the origin. So we would have that graph there. Maybe I'm going to try at the origin. And then because of the effect of p, our p is 1, it seems to have moved 1 point to the left. Are you noticing that? It seems it was at origin. If this the graph we're referring to is negative x squared, you can try to draw it as well. It was at the origin, and then if we say now y equals to negative x squared, oh, so it's actually just going to be negative x squared plus 1. It seems that our graph moved to the left by 1 point, right? You noticing that it moved to the left by 1 point. So I want you to take a few things from here. The first thing you have to take is that this is actually called the horizontal shift. So this point P here is called the horizontal shift. We said Q was the vertical shift. It's the movement up and down. P is our horizontal shift, and A is just determining whether our graph is faced up or faced down, right? So if P is if it's plus P, we know that our graph is going to move that point to the left, and it must be in brackets, right? If it was x minus what did we say, minus 1, our graph is actually now going to move to the right. So that is the distinction. Let me repeat it again. If here we said our x was x plus 1 and our graph moved to the left by 1. If it was x minus 1, our graph was going to move to the right by 1. The same thing if x was plus 2, our graph is going to move 2 points to the left, right? And then if x was minus 2, our graph is going to move 2 points to the right. So try to draw these graphs where it moves to the right, it moves to the left, right? So that you can actually see what happens, the effect of all of these parameters. The last thing I want to mention before I end this lesson is that the important thing is that what I wanted to mention is that sometimes you're not given your function in this form, your quadratic function in that form, and instead you only given it, maybe they say y equals to negative x plus, oh I'm lying, negative 2x negative 1, right? So it means you have to now use your ability to factorize to write it in this form so that you can actually know the shift, right? So you'll say, okay, I can simply open two brackets and then take the negative out, right? And then you have x plus 1, x plus 1. So it's two brackets with the same thing, you can just square it, right? So you have to know how to factorize if you're not given the formula in this form, but you're given it in this form first, right? So that skill that you learned previously about how to factorize is going to be important in this regard. So I'm hoping that clears any misunderstanding you might have about quadratic functions. And in the next few lessons, I'm going to do the other graphs, your hyperbola, your exponential, and also those trigonometric functions.